Welcome. Today in Organic Chemistry 2 lab, our one and only technique lab. All the other labs in the semester, we will be producing products. Today, we're going to use a technique called spectroscopy, and indeed three different types, UV, IR, and NMR. Okay. And spectroscopy is a generalized term that a variety of techniques fall into because they utilize part of the electromagnetic spectrum. So we're going to use a very strong external magnetic field that's contained within our NMR device and radio wave pulses, which are the weakest part of the electromagnetic spectrum, okay, to elucidate structure or determine the purity. You can use NMR for both of those. Today, we're just using NMR to help elucidate or figure out the structure of an unknown that we have. IR spectroscopy, okay, we're using the infrared waves, those that are just underneath what most humans can see. Okay. To, oh my gosh, look at that, elucidate the structure or determine the purity. Today, you're going to use IR to help with further information from the NMR. Okay, so the NMR and IR unknowns are the same compound. But then after today, when you make a liquid product, you're going to run an IR and turn it into me to help me figure out how pure your sample is. Okay. So what's required of you for this? Okay. You're going to be assigned an unknown. You're going to take a small amount of it, run, capture, and print an IR. Okay. And we're going to go through that in the instrument room in a little bit. You're going to run, capture, and print an NMR. Okay, both of those are done neat. These are liquid compounds, so you don't add any solvent to them. You run just the compound. You're going to permanently attach the hard copy that you print out into your lab notebook. You're also going to need a copy that you're going to permanently attach on the copy pages. Okay? That is the only time the IR gets affixed into your lab notebook. Here again, after today, if you're running an IR, it's because you've made a liquid product. You're going to run, capture, and print it, but then you're going to turn it into me so that I can reference it while I'm grading products. Correct identification of which unknown you have using IR and NMR data, clearly indicated in written form in your lab notebook so that I can find it easily while I'm grading notebooks the first half of the semester, counts as 1/2 of a product grade, which would be 6 points. If you do not correctly identify it, but you have information that led there in your notebook that led to your misidentification, partial credit is available. If you don't have it identified at all, no credit will be awarded. It has to be there by the time I'm grading it at midterm for credit. Okay? UV or ultraviolet spectroscopy, we're using ultraviolet, that is ones that are just a little more energetic than most humans can see. And you can use it to elucidate structure, although most of the time UV is used to determine the purity of a sample. And as it turns out, it's also very useful to determine the concentration of a mixture, okay, as long as that mixture, here again, has a component that absorbs in the ultraviolet range, which is what we're going to be doing today. Okay? So you're going to create a standard set of serial dilutions. That is, you're going to use one standard and then different volumes of it, okay, and then make all the volumes the same, diluting with water, okay, so that the more of the standard you have, the more concentrated the solution is. Okay. The amounts are indicated in the PDF. Okay. You're going to measure, for instance, 5 milliliters of the 1% albumin directly into one test tube, and then I think the next one is 2 milliliters. Then you would use 3 milliliters of water to dilute that to 5. So that would only be 40% of the 1%. okay, and figure out the concentrations then for. To all of those, in addition to that, you're going to be assigned an unknown. Okay, you're going to have a test tube that has, I think it's 2 mLs of your unknown diluted to 5, and have that as well. To each of those, you're going to add 2 milliliters of Kumasi blue and mix them. Now you want to mix them without adding a whole lot of air. So instead of shaking them, rub them between your palms, okay, so that they mix, and then allow them to set. This semester especially, we're going to have the spectrophotometers out for you. Hopefully they will all be calibrated, okay, so that you only need to grab your cuvette. Now, when you do that, make sure that you are holding the ground sides and that the clear sides remain free of fingerprints. Okay, you're going to use 1 cuvette for the entire experiment. Okay, the instructions on the spectrophotometers say to start with the highest concentration, so the 5 ml standard. Okay, put it in, put the cuvette in it appropriately, read the absorption, record it, okay, and then move on to the next one. You might want to rinse the cuvette each time with a small amount of the next solution down. Okay, so pull it out, dump it in a waste beaker, small amount, kind of rinse it around, dump that, fill the cuvette, put it in the spectrophotometer, read the absorption, move on. Rinse the cuvette thoroughly though between the water blank that has Kumasi in it and your unknown, so that you know that that is strictly the unknown giving you that absorption reading. Outside of class, you're going to want to graph the absorption values, okay, versus the known concentration. So the concentration goes on your x-axis, that's your independent variable. The absorption at 595 nanometers is on your y, as that's your excuse me, dependent variable. And then you're going to apply what's known as a least squares fit approach. Now, least squares fit are straight lines. This may not be, okay? But you don't necessarily want a point to point. You want a nice, smooth line, as close to as many of the points as you can get, but still remain nice and smooth. Use that information to extrapolate the concentration of the unknown using that standard curve. So once you have your nice smooth curve, read along the y-axis to your absorption of your unknown and move over. I'll show you this in just a moment. Correct identification of the concentration of albumin, and that's concentration of albumin in your unknown, where I can find it in your notebook while I'm grading, is the other 6 points for today's lab, the other half of the product grade.